Okay, this is your brain mind box is gonna explode after this. No, it's not. You're not gonna die. Settle down. Sit down. All right. We already know that the derivative gives you a formula for the slope of the tangent line. And I'm gonna put that in quotations. So, anytime you think derivative, you can think of, oh, it's the slope of the tangent line. You can also think that it's a rate of change of the x. I mean, we'll get into that a little bit later, but it's also a rate of change. I guess I'm going to write that too. But we'll look at this as moron. That's funny. What I want to do in this video is look at graphs and try and pick out spots for the derivative, pick out some characteristics of the derivative based on a graph. Okay, so let's look at that. All right, the graph of f of x is given. State where f prime is greater than 0. What does that mean? Well, first of all, let's say that this is f of x and f prime. Okay, this is the derivative, but we can think of it as the slope of the tangent line. And it's asking, okay, where is the slope of f of x? Where is the slope of f of x? Because that's what this is saying. F prime is the slope of f of x, or that's how we can think of it. Where is that positive? Meaning, where does it have a positive slope? Where is this function going upwards from left to right? Let's try and draw a few tangent lines. So I'm going to look at, I don't know, maybe the tangent line there. That would be something that has that kind of slope. Oh, that's positive. So, yeah, we're going to have an x interval. It looks like it's positive there. Maybe at this point, we have a 0 for the slope. So right there, we have 0. That's interesting. Oh, beyond this point, somewhere like right there, it has a negative slope. Okay, still negative slope. Right here we have a 0 slope, and then here we go back to positive. So I'm just like picking points on the graph and seeing, oh, the tangent line has a positive or negative slope. That's what I'm looking for. Okay, so I need to state the intervals where the slope is positive. That's easy. So I already know that we have a positive tangent here, a positive slope, and from 0 to, it looks like -3. -3. And, well, it's not positive at -3, at -3, at the x value of -3, the slope of my graph is 0. So I don't include -3 because it's not greater than 0. It looks like it's equal to 0. So I do that, but there are more. Perhaps you should figure out the second interval. Maybe pause it, because I'm going to pause it and then I'm going to do it. Okay, you didn't pause it early enough. Maybe you did. I don't know. But on the second interval, or for the second interval where the slope is positive, is right here, is in this area. What is that? 1, 2, 3, 4. And so I'd say, and 4 to infinity, if it continues on like that. So these are my two answers. That's where the slope is positive. It's negative there, and it's 0 here and here. That's all I'm saying. We can think of it like this. If you are on a roller coaster, say like it's like Donkey Kong. You're in the railroad, on the mining cart. If you're going up, that's a positive slope. If you're going down, that's a negative slope. I'm always going from left to right. So I have a negative slope and then another positive slope. At a turning point, whenever my cart is completely flat, that's where I have a slope of 0. So, yeah. That's maybe how you can think of it. Only if you're going from left to right. So, maybe I'll write that down. So if you're climbing up, the slope of the function is positive, which means greater than 0. Let's see, if you're falling down. If you're rolling down a slope on a roller coaster, that means your slope is negative. And then the last one, if your roller coaster cart, if you're at like a peak or a valley, if you're at a turning point, then the slope is negative. No, sorry, the slope is 0. So you have all of those things. That's one way you can think about it. Yeah, if your slope is positive, the function is called increasing. Oh, I should write that down too. If your slope is negative, the regular function is called decreasing. And if you have a slope of 0, it's neither increasing nor decreasing. Oh, that's pretty nice. Let's try another one. I should also draw the function, huh? Maybe you should pause this one and try it yourself. Give it a rough estimate for the x intervals where the function is increasing. That's what this means. Or where the derivative is positive, meaning the graph of the regular function is sloping upwards. Oh, sorry, that's negative, sloping downwards. And then where it's equal to 0. Maybe you should pause it and try this. Okay, I'm going now. For f prime being less than 0, that means the slope of the function is negative. All right, let's look at that. Where is f prime negative? Well, if this was a roller coaster, I'd say from about this point till this point. That green section, I'm sloping downwards from that's right. I'm falling down. Okay. What's that interval? Maybe negative 6.5 all the way up to, looks like 3, positive 3. That's where I'm less than 0. Okay, that's pretty cool. Now, where am I equal to 0? Well, if I had a roller coaster cart on this, my cart would be level right here, right at that point, and also right at this point. I'd be level. Then I'd have a slope of 0. I'd be neither increasing nor decreasing. So we have something like that. Maybe I should say on this interval, on that interval. Yeah, there we go. Cool. I'm gonna write down some more notes and continue this because I think this deserves some more examples. Goodbye.